So, well, it brings me to the next question on the list, which is, will we see tangible results in our lifetime, or is this all forward in the future? We kind of touched on that right now. I personally think in 100 years, we are actually, well, not we, you and I, but we as the mankind here on the planet, we will actually profit from space mining. Would you agree with that?
Yeah, I think so too. I mean, the inevitable fact is that we are going to run out of metals. Now, we may have hundreds of years of iron left, but in terms of sort of the rare earth elements, for example, that we rely on for things like, you know, electric car batteries and even our phones, that stuff is becoming increasingly more difficult to find. It gets extremely expensive to mine. And it requires us to start thinking creatively as to where else we can get this material. Now, one possibility that folks have looked into is there is a lot of this stuff on the ocean floor, but getting there is extremely expensive. There's a lot of this stuff in things like near-Earth asteroids, but getting there is also really expensive. And I don't know if it's going to be more or less expensive to go to an airless body and pull it back, or go into the ocean floors. But we're going to have to go there sooner or later, because I don't think humanity is going to want to give up its mobile phones and its electric cars and all these other technological gizmos we have. So we are going to have to face with a reckoning in the relatively near term, 10 or 20 years, within a generation, as to where we go get that stuff. And the good news is there's an awful lot of it way out in space. We just have to go there. Now, what is exciting is in the last few years, NASA has begun to seriously get interested in how we would actually go and operate in what essentially are zero-G environments, because asteroids tend to be so small. Even the relatively big ones that, say, wiped out the dinosaurs, they have no meaningful gravity on them. Now, that's a good thing for extracting resources, but it's a bad thing for how we would safely operate things. However, within the next 4 weeks, NASA has a mission right now called Osiris-Rex, which is going to sample a bit of an asteroid called Bennu, which is a C-type or carbonaceous asteroid. And it's going to do what they call a touch and go. It's going to basically high-five the asteroid and kind of hope to gather a few tens of grams of material and bring it back. That is going to be the first time NASA will ever have developed any kind of technology to actually retrieve material from an asteroid. Now, it's a long way from mining it, but it's the sort of thing that we're already getting experience in navigating spacecraft close to asteroids. In fact, the Japanese Space Agency late last year did their own sampling of an asteroid called Ryugu. And if you go to YouTube, there are some spectacular videos of the sampling process where they go down, they release jets of nitrogen, and it blasts material off. And of course, there's a real risk there, because now you've turned shrapnel. And the real worry is you don't want that to basically punch through your solar panels. But the spacecraft successfully took that sample. And later this year, Hayabusa 2, the name of the spacecraft, is going to fly past Earth. And as it does so, release a canister, which is going to enter the atmosphere and be picked up in Australia. And we're going to have some samples of this asteroid Ryugu. And in about 5 years' time, we're going to have samples from asteroid Bennu. So we're learning how to fly to these things, navigate spacecraft at them, retrieve material, and bring it home. Now, again, like I say, that's not mining, but it's the sort of critical first steps that we need to take to be able to mine. So we're already beginning to see the kind of technology we need being developed to actually one day make this a reality.
Wow, this is fascinating. I had no idea. I mean, this is quite a step further than I thought we were. This is great. Let me come back to one of the points you raised, and that is submarine mining. I'm currently involved in a project on exploring some submarine volcanoes for resources around the Canary Seamount province. I've been on some research cruise quite a while back, but we have recovered the samples now from the rock store, and we're looking at them. And there's a lot of encrusting manganese crusts that bring a lot of cobalt and manganese, obviously, and other things we need for batteries in particular. Electrifying the traffic will be an enormous thing. I mean, to electrify just the UK and Ireland will use up something like 70–80% of the world production in these elements right now. Right. So, and that's just two small countries at the edge of Europe, if you get my drift. So, but I see one problem here, and that's not in the list of questions, but let me quickly raise that if that's okay. And that is, submarine mining comes at a high price, and that is we will destroy some submarine ecosystems. Right. Because some of my samples, they have little coral fragments and things like that, or corals that have grown on the manganese crust, and that's a vivid reminder that there's life down there. And my experience from one of the recent eruptions in the Canaries, there was a submarine eruption in 2011, and a lot of the fish population died off because of the eruption. So if we mess around down there, I have an uneasy feeling about that. Obviously, if we're on some asteroid there's less of a chance that we're disturbing any life forms there. I mean, what
Yeah.
do you think? Is there any life out there?
We have some tantalizing evidence that there might be some weird stuff out in different parts of the solar system, but asteroids is not it. I think
That's
we're
my
good.
thinking as well.
I think we're good.
So my gut feeling would be that would be preferable than in destroying habitats for species on the ocean floor. So, but
Absolutely.
time will tell. So.